In this video, I'm going to show a little bit about some processing that is kind of experimental in processing data from the Raven. So this is an interior scan of part of a house, and what I did was include processing that did a Fisheye-to-Cubemap conversion after aligning the fisheye images, and taking that sparse point cloud and combining that with a colorized Lidar point cloud as the initial PLY file for training with LichtFeld Studio. Okay, so what am I doing here? Basically, I do a lot of Gaussian splatting with cameras, but they don't work well on interior surfaces that have textureless walls, things like that. So I did get a 3D Maker Pro Raven, which has LiDAR, as you can see in this image, and also has two fisheye cameras. Now, there is Gaussian splatting that's offered through the RayStudio software that's provided by 3D Maker Pro, but that does generally a pretty terrible job. So I'd worked with Alex Guy to develop a process for splitting up fisheye images into cube maps, and that gives the full field of view coverage, which gets included then in Gaussian splats. But textureless surfaces don't work well. So in this video, I'm showing a process that I developed that's kind of experimental to try to merge together a sparse point cloud from Agisoft Metashape. When it aligns all the photos, I align the fisheye images and then later split them to pinhole images for the Gaussian splat training. But using that Metashape produced sparse point cloud, I merge it with a RayStudio processed and exported colorized Lidar point cloud and initialize Gaussian splat training with that. The hope is that these flat walls that don't have any textures on them will train well, and the Gaussians will be locked onto those points. I show a process here and the training process and everything. It's not meant to be able to lead you through that whole process, but someone who's a little knowledgeable in this area should be able to follow what I'm doing and see that the results don't really lock those Gaussians onto the LiDAR points on the walls, and we still get a lot of bleeding through to the room. Anyway, watch the rest of this video and you can see what I did. This is a folder view of the fisheye images that were extracted from the ROS2 file using RayStudio, and then I ran a Python script to pull out 2 frames per second sampling from that. So there's 2 displays here. The left is the left camera images and the right is the right camera images. So this is just a small fraction of each, but this shows what the images from the Raven look like. They're portrait, and they have this fisheye image in the middle, and they're kind of a little bit cropped on the left and right of that circular fisheye area. This is a similar folder view of the masks. So I hand drew masks, one for the left and one for the right of the kind of circular area that's a valid image area. And then I ran basically a SAM3 based masking to mask the camera operator, me, out of the images. And this is just what those masks look like for a small fraction of the images. I did an alignment in Metashape and then exported a cameras file and a sparse point cloud file, and using those, then I was able to go ahead and break up using a Fisheye-to-Cubemap conversion into these pinhole images. I actually first combined the sparse point cloud with a colorized Lidar point cloud, and I'll show that in just a moment. But using that conversion script, basically, I was able to create a CoLMap data set and create, as part of that, all these images and masks, and you can see how they're split up here into pinhole images. So this is in Cloud Compare, and this is the sparse point cloud from basically from the photogrammetry processing. So this is just from the alignment in Metashape. I took this and I registered this to the Lidar exported point cloud, and so if I turn this off, I can turn on the Lidar point cloud, and so you can see how this looks. And I don't know what this is. This is probably a duplication or something because of looking out the window. Windows on this side or something like that. And probably the same thing here. So I'll bet those are extra ghosts from from this big set of windows on this side and the big set of windows on the other side. But since I registered these together, transformed basically this LiDAR point cloud into the space of this, if I look at both of them, they align. And so I can click on and off here. And so these two are aligned together. We can go down and look much closer, say, inside one of the rooms here. And look at, say, these chairs or something like that. It's hard to not look through other things, but we have a clock on the wall, which is closer to me than these chairs are. But if we kind of get a view like this, then if we click on just this is just the sparse point cloud, and we can turn that off and then turn on from the LiDAR. And so those two things look pretty different, but they are indeed aligned together. You can see if I click these on and off that they match up just fine. And so basically what I did was I took the color point cloud that was LiDAR and aligned it to and transformed it to the sparse point cloud. And then what I did was basically I merged those together and exported them. And so I used that then as the initialization when I used LichtFeld Studio. So I had a Cubemap folder, but I overrode the starting point to, instead of using the sparse data set that was part of the Cubemap data set, I used the sparse cloud that was part of, or sorry, that was this extra one. Now this has like almost 20 million points in it. I probably should have thinned it first, but I didn't do that. So that's why I ended up training to about 20 million points. So I've already run LichtFeld Studio, but I'm going to show here just what the scene looks like. So we had merged the point cloud from the LiDAR and from the sparse point cloud that was produced by Metashape when we did the image alignment. So this just, I wanted to kind of show the full camera trajectories that I had run across multiple rooms here, and then going up a stairway. This is a skylight up out the top, so that's actually real data up there. These things out on this side and this side are duplicates of this from Windows. And when I did the training, I ended up capturing a view through the training, so we can see in just a moment a video of a view, something like in the kitchen here, looking up over this countertop and seeing the ceiling and things. So it was a camera somewhere in one of these pointed in this direction. And so we'll be able to watch a video through the training where every 200 iterations it saved an image. Anyway, so that's just kind of what the data set looks like overall on input to LichtFeld Studio. So this is what the training went through. So this is every 200 iterations is a frame, and these are played at 30 frames per second. So we can see that you can see down this hallway and a mirror here. You can see generally things getting clearer as the training goes along. But we'll see that later in the training we end up with a whole bunch of stuff in the space here, which is just kind of garbage. We can see, things do look pretty sharp overall. This was an MC training, and I slowed like all the learning rates a lot, given the large number of images. Now, I trained to 1 million iterations. I don't know, it took like 6 hours or something like that, given nearly 25,000 images. We can see here this is growing. We can't see this mirror anymore down here, but be interesting probably to scroll through this video back and forth and see what gets better and what gets worse. It seemed overall that a lot of these flat areas ended up picking up kind of a lot of like low frequency kind of garbage as we trained further. I don't know if that's just the nature of the training where you start stealing Gaussians because they can get bigger here in order to try to get even sharper details where there's a lot of local image modulation and maybe more photos, more coverage. But you can see this is growing, and we can't see into the other room anymore. We can't see down this hallway anymore. And not sure if it's, some things with different exposures. The alignments seem to really be pretty good. And when I, fly around or something through the final train splat, things look pretty sharp on all the walls. But I will also show later on that the walls do kind of end up bleeding out. I'd hoped that the LiDAR data would provide good points on the walls, the flat textureless walls, but it didn't really work as well as I'd hoped. You still end up basically bleeding out on those walls and poofing data out from those flat surfaces into the space. Similar issues that you see if you just initialize with a sparse point cloud from photo alignment and don't use the LiDAR. So I don't have an exact comparison of those. You see how much garbage we're getting in the middle here now. So but we still have good sharp edges on a lot of things. So I think I need to learn a little bit more about training, see if there's a better way to lock to the initial points or something like that. Anyway, we're getting close, up to basically around 1 million iterations. So this is the final result. Now we probably did overtrain here because, as you would note from just seeing the video through the training from a view something like over in here, it's hard to get the exact view. You can see we have all these floaters out in the middle of space. But, I mean, there is some nice sharp, like the countertops. These lines look pretty good. These metal rungs of the drying rack, right? I mean, there's a lot of sharp things here, but we have a lot of junk as well. If I go ahead and move forward through here to go into the other room, you can see how much junk there is here. But yet things on the walls, can be pretty sharp as well. So let me try to steer over here and go into this other room here. So you can see that, there's things that look really sharp, like these stones, everything around here, the patterning on these chairs, the picture, the clock, you can read the numbers and everything. Yet if we go and look, kind of drag up to look to see how the wall is, even though we started with the LiDAR data, it still exploded out into the room. So even though I turned down very much in the training, like the position sort of that it can shift, it still didn't like lock onto the points of the wall here, unfortunately. And so I'm not sure how to try to get the LiDAR to work best. Just initializing by merging them together doesn't seem to do the trick, and we end up with a lot of other junk in the room here that we wouldn't like to have. So I still need to figure out a better method. It's not just getting a combined initial points, because that would get very much points on these walls and things from the LiDAR data merged in there. But something it's still like drifting throughout the training process that's not giving us what we'd like. That's it. I would like to give a shout out to Alex Gee, who collaborated with me and worked on this Fisheye-to-Cubemap conversion, and Alex did a great job continuing that work and also embedding in that processing a Cubemap conversion, so you don't need to, after you break up the fisheyes to the cube maps, you don't have to realign again. If you've aligned the fisheyes, you can carry that through in that conversion process. Also, thanks to Alex for some of the SAM3 based camera operator masking that he gave me as well. Thanks for watching.